This is actually what we use to measure the fish biomass. We've got our diver here who will swim along a 30-metre transect, and then a fish will swim in the front, which will be identified at least to genus level, but preferably species. These are in 10 centimetre increments, so we'll probably hold the stick up and go, okay, this fella looks like he's 30 centimetres, and it's just an estimation as well. So we've got something down here called the A and B values. Just so you guys get a grasp of what these things are. We get these from a special science paper where these are logarithmic values. Could anyone guess why we'd have different A and B values? Okay, so basically for morphology, right? So if we look at the great barracuda here, the way that the fish is, the morphology of it is completely different to our white-spotted filefish. So if we had a 20 centimetre barracuda, for argument's sake, and a 20 centimetre filefish, and we wanted to estimate the weight, if we just used the length and everyone had the same A and B value, then we'd get the value every time, which wouldn't really show us anything. So by having different A and B values, we can get somewhat of an estimation of the weight of the fish. Fish density is basically count data. So we do again our 30 metre transect or 60 metre, depending on what floats your boat, and then we basically so our count data would be, our density would be 0.8. So we talked about the MPA, and we want to see the effect that fish biomass, so fish biomass. In the tan colour here, we have got inside the MPA. In the blue colour here, we've got outside of the MPA. I spoke to you guys a little bit about those standard error bars, which you can see here. Some of them more. But what I wanted to see in the MPA was having an effect on fish biomass, which, as you guys can see, it is. Some years it's significant, some years it's not. But in general, fish biomass is significantly higher inside the MPA than outside of the MPA, which is, somewhat the MPA is doing its job. Does anyone know what this is? Anyone know the scientific name? Epiphyllus striatus. Okay, so you guys have been doing your group of workshop, right? So yeah, I'm going to talk to you a little bit about some of the long-term projects outside of CCMI that have been going on with the spawn and aggregation zones. So yeah, this is a population count of them spawning aggregation zones. So this is at the spag zones only. So in 2003, Moon Project wanted to address some policies that needed changes in terms of protecting the grouper. So yeah, since 2003, they added legislation. They kind of wanted to see if you could recover a fish spawning population which had collapsed. So there was an exploitation of the spawn and aggregation site. We have got 2 in Little Cayman. There was 5 in the Cayman Islands, and we're down to 1, which is on the west end of Little Cayman. But what they found was that spawn and aggregate, the population could recover. So there are still limitations for catch. So you guys were saying you could take one grouper between a certain date in your workshop today. What the DOA have out is 5 groupers per vessel outside of the MPA in open season. The MPA, the grouper are fully protected throughout the year. The open season's through December to April. Sorry, that's the closed season. Open season. Through December to April, even in the non-MPA. So that was the blue zone around the outside of the island. So yeah, and there was a fish catch size, so you could only take the grouper between 16 inches and 24 inches. So that protects that strong adult population. Interestingly, what this data also found was that every grouper that was acoustically tagged of sexual maturation size always went back to the spawn and aggregation, so at 100% return rate if the grouper was of sexual maturity, which is pretty cool. So what we wanted to see was grouper biomass. This is our data from our long-term monitoring over time. So grouper biomass has significantly increased, which kind of goes with this figure here. you can kind of see the same kind of trend, even though this is all around Little Cayman rather than just at the spag zones, which is, it's really cool to see. So yeah, so our adult population is protected, our group is getting bigger, which means that the spawn and aggregation zones will probably be more successful. And hopefully there is one on the other end of Little Cayman which they are monitoring. It's still protected. It's not being used by the group as a spawn and aggregation zone, but they are hoping that the group are going to return to the spawn and aggregation zone. So another fish question, guys. Who knows what this is? Oh, so good. So this is stoplight parrotfish in its terminal phase. Does anyone know why parrotfish are so important to the reef? Nice. Yeah. So they're super important grazers. So our parrotfish density has significantly increased since 1999, which is really, really cool to see. They're a key herbivore on a reef, so we do need them. They graze for 90% of the day. So yeah, this is a really cool trend to see. And they are related to our benthic communities, right? So we get this thing called a feedback loop. So if we had low density parrotfish, we'd have too little grazing intensity, which we can see there. So I'll just let you guys take that in a little bit. So if we were in the too little zone, we'd have reduced structural complexity. Do you guys know why structural complexity is important with our reef? Yeah, like a nursery area. Go on. So yeah, reduced structural complexity, reduced fish recruitment, so less fish, reduced grazing intensity, increased macroalgal cover, which we're going to get into, coral recruitment decline, again we're going to get into this, and reduced coral cover, which is bad times. But if we get to the threshold and surplus, then we get our positive feedbacks as well. So it's basically the complete opposite of the negative feedback. So we'll have a look at Little Cayman and kind of link these two things together in a minute. And we get this thing called a phase shift. So this is coral dominance when you get 50 to 100% of coral cover. So you can see in the bottom, this is from 2009 paper, you can see the bottom right there, which has got high coral cover. And you get this phase shift sometimes, which is algal dominance. So it's going to go about algal dominance is algal cover between 50 to 100%. Algal dominance is bad because you do get a breaking point with this where it's hard for the ecosystem to recover. Like it would take a lot of energy for the ecosystem to recover back to the coral dominance. Algae is so quick growing compared to the coral. So yeah, which is called the Ali effect when it gets too low. So I've been digging out some meta-analysis. Like I absolutely love data. So I wanted to find somewhere in the Caribbean, which is like general, like I wanted a big data set. So this is in the Mexican Caribbean. This is the general trend for the whole of the Caribbean. Not the whole of the Caribbean, there is some play in that, but for this, we're seeing hard coral cover, which is what I'm talking about when I talk about coral. There's been significant declines in hard coral cover since the 1980s. And macroalgal cover has significantly increased. But here in Little Cayman, it's a bit of a treat. Our coral cover has stayed fairly constant, which is quite amazing to see. And our algal cover has actually significantly declined, which is pretty amazing. So if these trends continue, hopefully we could get back to coral dominance, which would really, really be cool to see. So again, we talk about those key herbivorous species like parrotfish, and our densities increase at the rate that our macroalgae significantly decreased as well, which is really, really cool. But at the same time, we are seeing a significant decline in coral surface area. Can any of you guys think why coral surface area might be declining? Jana, you had a good point earlier. Go on.
Rising sea temperatures.
Rising sea temperatures, what would that cause?
The coral bleach.
Nice.
Stress.
Yep, so stress events do reduce the surface area of coral. Jana, you said one in the office earlier?
Yeah, change in the species that are dominating the reef.
Yeah, so we also see like a change in species composition as well. So what I did for the next bit of data was I found out the top 10 coral species and then filtered them into their genus. So I want to share with you now the large reef building Sclerotinia. So you've probably seen this boulder star coral, Orbicella annularis, when you've been diving. But again, we talk about reduced surface area. At one time, you see all the grey around it, that was probably completely covered in coral, but due to stress events, we do get partial mortality of these colonies. Got Montastria cavernosa, again, pretty common on our reefs, the great star coral. And then we've got symmetrical brain coral, Pseudodiploria strigosa. We've also got Siderastria as well as one of our main species. But we're seeing a slight change into these smaller species. I know you guys have probably seen thousands of these things, right? They are fairly resilient, they're doing really well, they're of least concern of the UNDP conservation list, whatever it is. So yeah, they're super small, they grow small, but they're fast growing and you know. So I can't physically show you the difference in surface area between those big species that I was talking about, but again, I like to put it in a figure for you guys to see. As you can see, Orbicella is by far the biggest species, right? Which is this one here. And then we've got Pseudodiploria strigosa, which we saw. This is the genre. And Montastria. And then we've got Siderastria. So these 4 species are all significantly larger than AGRRA and Parietes, which are those smaller species. So this is a adult coral species composition figure. So what I do is I take the count data and then I turn it into a percentage. So how much of that count data these different genera are. As you can see, back in 1999, Orbicella is, it's quite dominant. It's the most dominant coral genre there. And as we come through time, we kind of funnel into this smaller. This is where we're at now with Orbicella. The orange at the top is AGRRA, so the small lettuce coral species. As you can see, that is inclining as to where we are now. Montastria stayed fairly stable until around this bit here, where we've seen decline in that as well. Pseudodiploria, similar story. And Siderastria's kind of done okay. It's as to where it is, and the last 3 years it's not really changed too much at all. So I talked about the species shift, and I talked about why we might be getting smaller surface area with our corals. As you can see, those 4 major reef-building coral colonies have declined in size. Have declined as individuals as well. What I would say about this is every single one of these corals has significantly decreased in surface area since 1999, even AGRRA and Parietes. But as you can see with the adult individuals here, we've had significant increase in AGRRA and Parietes. Does everyone know what a coral recruit is? So a coral recruit is basically like a juvenile coral, like a baby coral. When we measure it for our data set, it's corals which are below 4 centimeters. So like half your pinky is good. So do you guys know how corals mate, how they reproduce, not mate? Yeah? You know?
Don't they release their gametes at full moon?
Yeah. Yeah, so corals release. So we've got hermaphroditic, let's for this sake, we've got hermaphroditic coral here. So they release egg and sperm into the water column, where they fertilize in the water column, and then they settle on a hard substrate, or CCA. And then obviously we go through the phases of recruit, juvenile, and then brooders, which is a different reproduction, which I won't get into, is a bit shorter. But our big broadcast spawner is, it takes decades to get to that phase. Do you guys know how corals reach sexual maturation, where they can actually physically reproduce and put eggs into the environment? So that they reach sexual maturation through size. So if you've got a little coral recruit, then it's probably not going to release its gametes. So we talk about that surface area again going down, which could explain something I want to show to you in a second as well. So we looked at the adult species composition. This is the recruit species composition. What we can see here is Montastria has stopped recruiting since 2017, which isn't great news. You can see there's a lack of Orbicella on there throughout the whole data that wasn't in the top 10 species at all for our coral recruits since 2006. AGRRA is doing well, Parietes is doing well, Siderastria is doing well, and then we see these species hanging on at the bottom. So we've got Stephanacina, Eusimilia, Mycetatophilia, which are these guys. So our Montastrias can grow up to 10 feet, as per the coral guide. So they're really, really big corals. These guys, max size, we're looking at 1 to 2.5 feet. So if we saw that, shift in species, then these reef-building corals protect our coastline, right? They absorb up to 90% of wave energy, which is huge. So if we see this shift from these big species to these smaller species, and we've got rising sea levels, then that could be a massive issue for a lot of island nations, as we see over in the around Samoa and places like that. They're also worried about losing the islands, right, due to the rising sea levels. So what I finally want to talk about is our recruit count over time as well. So no matter how we look at it, the adult population of AGRRA and Parietes is significantly increasing, but our recruit count is still massively declining. These are all significant. Like I said, Montastria has stopped recruiting since 2017. Orbicella has been so low. Apparently there was one last year. But in the wider Caribbean, there's been a lot of reports that Orbicella has also stopped recruiting. Does anyone know why that could be an issue for later on in the game? Okay, so if we've got an adult population, so let's look at Orbicella as an example. Orbicella is really susceptible to yellow band disease. So if we get a bad whack of that or whatever, and we lose the whole Orbicella population, this is doomsday, but it's unlikely to happen. But we've not got recruits to come back. We've not got any recruits to build it back, so we could be facing local extinction of species in this way. You've obviously got other events, storms, which can really, really hammer the corals, bleaching events, disease outbreaks, anything like that. So overall, our hard corals have seen, this is just our 5 adult species, just have a look at the recruits. But overall, our coral recruits have significantly declined throughout all our hard coral species. Back in 2006, when the data started, we counted 1,200 coral recruits on our transects. Last year, we counted 256. So there's a huge difference between 2006 and 2022, 16 years. So hopefully it's a trend and it will fluctuate and maybe come back up, but we'll have to wait and see in the next 22 years of our data collection. So I just want to give you guys a quick summary of what I've got stuck into tonight. So we learned about the MPAs and the legislations and the protection of what they offer. So again, we go into these policies, and Nassau biomass has significantly increased, and the spawn and aggregation zones are protected. So our policy and legislation around the island are working. Parrotfish densities remain constant, so that whole connected ecosystem is really helping our algal cover significantly decrease, right? Coral covers remain constant, so all that healthy fish population is helping us get to where we want to be. Coral surface area is significantly decreased, which is quite alarming. And we've seen this species shift from those big corals to the smaller corals. And coral recruits have significantly declined across all genera, which is bad news for the long term of coral reef health. So cheers for listening, guys. Thanks for coming out. And have you got any questions? Yeah, no worries. Yeah.
So you're seeing a decline in more of the larger reef-building corals. Is there any type of plan that to help increase the populations of those corals again, or?
So for you guys at home, the question was, with our large reef-building corals declining, is there any plan to increase our population of large corals? CCMR, we've got restoration programs going on, but we are focusing mainly on AGRRRA. It's a toughie. Restoration itself is a really, really tough topic to get into. There are places around the world which are trying things, some successfully, some unsuccessfully. There is no fully agreed method right now which is working. There are bits, don't get me wrong. But yeah, restoration science is hit and miss. So, but yeah, it would be really, really cool if there was an agreed upon method. And again, it's a local thing. Things could work one place and not work the other place. So, but it would be cool to do, yeah.
Is there any data showing that corals might be evolving to try and grow in deeper waters where the temperature is lower?
We've not looked at that, but I think you guys have got a project on that, right? Looking at.
Me?
Yeah. Would you like to have a? Sorry.
If you can just come up. We can so repeat the question.
Yeah. So the question was, are we looking at, is there any data to show migration of corals to the deeper depths where the water temperature is cooler? Want some of this?
You can just stand nice and close to Matt. We can put that on the...
Yeah, there's actually a lot of research going into how corals could potentially live in deeper waters. There's a whole theory called the deep reef refugia hypothesis that suggests that corals that reside in deeper parts of the reef could survive better in terms of bleaching and storm and all sorts of other impacts. And then in the future, those corals could repopulate the shallow reefs after they have been degraded and conditions return to what they would normally be. And so right now it's sort of in its, it's still in its infancy. I would say the field of mesophotic science is what we're talking about, is only about 10, 15 years old. So we're still actually just documenting what species live in mesophotic reefs, how they're able to survive in low light environments, because corals obviously need light to feed. So there are restrictions on their growth, their reproductive output, all other sorts of trade-offs associated with living in colder water and in water with less light availability. And then also, if they can even reproduce and if their larvae can recruit to shallow reefs to restore degraded populations. A lot of what we're finding actually is that many species are able to thrive down deep as 100 meters in some places. And some of those are reproducing. In fact, the team that was here just a few days ago, I think you guys probably saw them around. I sent the graduate student their samples several years ago from 60 meters deep, and she did find eggs and sperm in those corals. So they are reproducing. And there's a lot of modeling work that's showing that they can, in fact, recruit across, but it's more likely that coral larvae are recruiting deeper than shallower. So those corals that are living shallower, their babies are actually settling and then growing happily in the deep, but not necessarily the other way around. And then we have a project at CCMI right now that we're actually looking at morphological and genetic adaptation of corals in mesophotic reefs to see if how they are able to survive and what that will mean for the future, whether it's genetic adaptation or just individual plasticity or changes in individual morphology that allow them to survive.
Nice.
We've got a question from the online audience. And Gretchen, you may want to stay close. The question is, does coral have carbon sequestration capacity like mangroves, for example? Do you want to answer that?
You go for that. So the question was, does coral have carbon sequestration potential like mangroves?
What do you think, Matt? Putting you on the spot.
Yes.
Yes, of course it does. Corals are photosynthesizing, so they are uptaking CO2 from the water and producing oxygen. So yes, in fact, corals are a carbon sink.
Great.
Yes.
Nice.
Thank you.
Yep.
This might actually be more related to what you're
Oh, yeah, just stay up here, Gretchen. Yeah. Have it.
So hypothetically, if the shallow corals were to all die off and all that would be left are the deeper corals, which seems like things are going that way,
Right.
would those corals still absorb the wave energy like the shallow corals, or is that going to be an issue for those corals that we'll have to deal with?
That's a good question.
So let's repeat the question and then...
Okay. So her question was, if we lost all of the corals in the shallow reefs and all we were left with was deeper corals, would that affect their ability to absorb wave action from hurricanes and storms and things like that? And the answer is yes. Because they're deeper, they will absorb some of that movement of water as it first hits the slope, as it's approaching your island. But when it gets closer, you really need that high topography, that big relief of the reef to absorb the majority of the impact of the surface water that's entering your island ecosystem. So without the coral there, you're still going to have structure. I mean, even if the corals die, their skeleton is left behind. The only issue is then that over thousands of years, they begin to degrade and erode, right? So this wouldn't be an issue that we would be dealing with in the next 10, 20, 30 years, but it would be in the next 50 to 100 years.
So you were, the data you're showing is mostly for Little Cayman, the bulk of it?
Yeah,
correct?
yeah, for sure.
Is there evidence or data for the other islands that you're seeing, that they're seeing similar redistributions of the different species?
I'm not too sure. Is this for the Cayman Islands as such? I'm not too sure. Sorry. Sorry. For you guys at home, the question was whether we're seeing the same shift in species across the whole Cayman Islands rather than just Little Cayman. This data is primarily for Little Cayman. This is the data set I've been working with. I do know someone who probably knows. Yes, it's the same. Yeah. But yeah, sorry, I've been working with the Little Cayman data, so I'm not 100% sure on Grand or Brack or anything.
Sort of a general question.
Yeah.
So I think sometimes for those of us who are not in the field actively with restoration and analyzing the data, or those at home, we feel the need to help and to do something to help, but perhaps we don't have the skills, we're not geographically located in the right area to be, volunteering. What are some things that people who live outside of the Caribbean can do to help support efforts for those who are, sort of like the boots on the ground?
So the question for home was whether there's things that you guys who are away from the Caribbean, is there any ways that you can help us guys with boots on the ground? Obviously the main thing in biology, restoration, conservation, research, whatever is cash. Everything's super expensive, especially marine biology. Everything is very inaccessible, such as boats, dive tanks, all of that. So yeah, obviously we do a lot of fundraisers throughout the year. It does seriously help us. Thankfully, we've got some really great stakeholders who fund quite a lot of projects for us. We've got Gretchen, who's sick at writing research proposals and getting funding secured. So she's amazing with things like that. So yeah, very, very, very grateful to be working with CCMI for her. So yeah, I think that's the main way. Obviously, education. I feel education is super important. If you can fix things at grassroots level, then you're going to fix it all the way up, right? So by spreading the word of what us guys are doing, like the education team are great. Vic will be surprised that I've said that. But yeah, so I really do think education is really important. When I'm in the UK, I go to the primary school that my friends teach at, and I always speak to the kids, because if you can make them aware at a young age. I wasn't aware of coral reefs when I was 5 or 6, I was eating mud and playing in the sand and whatever else. But it's great to get to that grassroots level, and if we can get into that area, then I think it's going to have a really, really strong impact in the future. Okay.
There are really great internships as well all over the Caribbean. So we're not the only people that are doing coral restoration. There are programs all over the Caribbean. There are programs in the Pacific. A lot of them are always looking for volunteers, for interns. So if you're really interested in getting involved with restoration, probably the main thing that you can do is volunteer your time. So going to these places and spending a couple weeks getting in the field and learning the techniques and helping out. And then, of course, there are all sorts of websites as well that can, just by clicking on the website, it's donating to your particular cause or helping remove plastics from the ocean. And these are just really simple things that you can do that you don't think about every day, and it doesn't cost you anything to do. So stuff like that makes a big difference. And then, of course, the biggest thing that all of us can do is reduce our carbon footprint, because unless we reduce the carbon in the atmosphere and halt global climate change, we're not going to be able to restore coral reefs to what they used to be, no matter how hard we try. So.
Nice. Yeah.
You talked a little bit about the phase shift from like a coral phase to like an algal phase. Is there any way to combat this, or is it just like outplay to try and prevent it from occurring?
So the question was, is there any way that we can combat this phase shift from coral dominance to macroalgal dominance? As Gretchen said, there's a lot of different programs around the Caribbean. I used to work somewhere that did diadema restoration, so basically the black spiny sea urchins, they're quite an important herbivore on our reefs. We lost them in, I think it was Hurricane Allen in 1995. And then we saw a significant decline in coral from then. There is a paper that links diadema abundance to coral cover as well. So that's good. So if you can restore herbivores in a way, then that's, that could work. Again, restoration ecology is a funny one. Everyone's got their own opinion on it. And but yeah, I mean, the thing is with technology improving now, like we're finding more and more different ways that we can do this. So I think finding that standardized method, on a local-ish scale where we can say, okay, the Caribbean, this is working, then that could be powerful and it could work. But for now, it's, not too sure. We don't do any restoration for parrotfish. We just have that management and then policies in place. So to see that having an effect and seeing the parrotfish density increasing, then that's obviously going to help our macroalgal coverage. So I think the UNDP one, they're aiming to get 33% of all the marine environment protected by 2033. So things like that, if we can get this policy and legislation right, then that can certainly help on a big scale.
I have just purely data question. So the increase in the genus Parietes, does that include the branching species or just asteroids?
Yeah, that's branching species as well. So this is Parietes asteroides, Parietes, the F. Yeah, that one as well. But yeah, it's all the Parietes are in that. Yeah.
My second question is there a correlation in the decrease of recruits with a decrease in CCA as well?
Not looked at. Would be interesting to see. Sorry, the question was, is there a trend with decline in CCA, which is calcified coralline algae, and coral recruits? I've actually not looked at that, but that could be very, very cool because obviously, that would definitely be worth something looking into.
You mentioned hurricanes a minute ago. How much might hurricanes impact the local data that you're collecting from each place and the effect on trying to get a unified approach to the coral restoration?
Could you just repeat that, sorry?
How do hurricanes affect your data, basically?
Okay, so the question is, how do hurricanes affect our data? Hurricanes can be really devastating for the coral reefs. So we could go and have, we could have this for ages, and then we could get some hurricane here, and this could significantly drop off. So obviously with climate change as well, we are seeing more and more extreme weather events, which includes hurricanes. So again, this is going back to the whole recruit thing, is if we lose our adult population, and our recruits are low, then that could seriously devastate our reefs here. Like you could see a change this time next year. It could be up here if Gretchen keeps me, and it could be completely dropped off. So yeah, for sure. Okay, guys, nice one.
Okay, thank you, Matt. We'll give you another round of applause at the end. So I've just got a little spiel about CCMI. So we are a non-profit organisation, and our mission is to sustain marine biodiversity through research, education, outreach, and conservation. So thank you guys so much for listening to this talk, because that's part of our goal, is to do that education and outreach. As Matt said, education is so important. The more people that are aware of these issues and read our Healthy Reef reports every year, the more knowledge you have, and the more you can be like, I really need to do my bit to help with global warming. So the different ways you can support us, Gretchen kind of covered a few of these, but you can support us by donating to us. We are a charity, so we've got our merchandise at the back of the room as well, and a little donation box. Those of you online, you can go onto our website to donate there. You can become a member as a donator. Also, your Cayman Airways miles, anyone that's travelled here, you can sign up to the Surf Turtles Reward and give us all your Cayman Airways miles. That helps us bring scholarship students over and our staff over as well. Make sure you follow us on social media, keep up with all the different things we're doing. We do have Friday station tours as well. If any of you are interested, tomorrow at 3 o'clock, every Friday, we do a tour of our station. We get to see all of our merchandise that we have, see the research labs, see the researchers hard at work as well. Spread the word about our programs. We have loads of different programs at CCMI. This summer we still have spaces for our summer camps, so make sure you spread the word. If you want some kids to come over, do diving, all the group here really seem to enjoy it. Saw a hammerhead shark the other day, which is awesome. And we said the main thing is reduce your carbon footprint. This really helps with the coral reefs. Your actions on land are impacting the reefs, so make sure you're doing your bit and trying to reduce your carbon footprint. And then here in Little Cayman, stick to the speed limit. We keep getting more and more of the Cicerone rock iguanas getting hit, so just my little spiel about trying to stick to the speed limit there so we can protect our endangered endemic species. Thank you guys so much. One last round of applause for Matt.
Thanks, guys.